Oh, wait. You idiot. A while ago, back when I was still figuring out how to YouTube on YouTube, I released this episode of me building a Dandanator with the Multiply add-on. The Dandanator is an expansion card for the ZX Spectrum range of computers that allows the loading of ROM images. It can do a few other tricks too, like being a diagnostic cartridge. The version you can see here is my original Dandanator Mini, and this part here is the Multiply add-on. The cable attaching it to the Dandanator is a little awkward in practice, with no natural place for the Multiply to sit next to or on top. I've cannibalized the chips inside this one for the Dandanator AMIE I have here. AMIE stands for Alias Multiply Integrated Edition, and you can find the GitHub link to this project in the description. This version integrates the Multiply and Dandanator onto a single board, leaving the joystick port in a really handy place right on top. Of all the versions I've seen, this is probably my favourite, being compact and less complicated than the one we will see next. But this isn't why we're here. Originally, Arcadesy off Twitter sent me the first Dandanator and Multiply add-on as a kit to build. He then also sent me the AMIE version. And being the lovely person he is, he sent me this MTD version too. The biggest difference on this version is the extra set of ROMs stored on the second NOR flash memory chip. The switch above here selects between the two sets of ROMs. This other switch is for pausing the Spectrum. I've not tried this, but it sounds like a handy feature I would have liked on my original Spectrum. Anyway, this isn't a tutorial or a guide to the Dandanator. This is a build video with lots of sexy soldering. No, I said soldering. Right, I better get on with it. Before I start melting things onto this board, it's a good idea to clean off any impurities and oxidization that will have built up on the surface. With anything like this, it makes the most sense to start with the stuff closest to the board. The SMD passives are all 1206, which means 0.125 by 0.060 inches. In metric, that's 3.2 millimeters by 1.6 millimeters, or in English, bloody tiny. This diode is the first to go on. These need to be put on the right way round, and if you look really carefully you can see there's a faint line across one end. This is the cathode end, or the negative side. On the silk screen you will often find diodes marked with a line across one end, but this one has the diode electrical symbol, which is a triangle with a line across the pointy end. Sorry to blind you with science. The line across the point indicates the cathode. I hear quite a few comments from people saying they find SMD soldering to be more difficult than through-hole, but I think once you learn how to do both to a decent standard, you might change your mind. There are lots of different ways to do it, and not all of them suit everyone, but my preferred method is to flood the area with some flux, dab a small amount of solder onto the end of my iron, and then holding the part in place with some tweezers, dab the solder onto one end of the component and the pad at the same time. I prefer this way as I have reasonably steady hands and it works for me. I know that others like to tin one of the pads, heat it and then slide the component into place. I find that easier to mess up and often end up dwelling with the iron for too long. How about a closer look? I recorded this quite a while ago, so the microscope I'm using is my old one, which, to be fair, did a decent job here. Capacitors next. All of these components go on in much the same way. The capacitors just stand up a little bit higher than the resistors. This PIC chip, PIC stands for Programmable Interface Controller, was programmed by Arcadesy in advance and is one of the other changes to the previous designs. This one is a surface mounted part, which I assume is cheaper. I think it's another reason to go with the AMIE version, as that one is all through-hole and easier to deal with. I have no idea how Arcadesy programmed this, but looking into PIC programmers revealed a minefield of devices that might be compatible, but also might not. The legs on this chip are nice and far apart, making soldering a doddle. Next is the GAL socket. A GAL is a type of logic chip which is programmable. This one I can program with my Mini Pro TL866. But again, Arcadesy programmed all of these in advance, so I don't have to. Next up is a PLCC socket, the first of two. It's important to observe the orientation marking on the board and align the socket accordingly. Failure to do this will cause extreme embarrassment if you happen to record and release the footage on YouTube. You have been warned. You can tell which way round the socket needs to go by the flat edge on one corner. Yep, this one is the wrong way round. Sometimes I could slap me. The SD card slot is a full-size one. I quite like these. They feel a bit more robust than the micro versions. Here I'm using a method that will probably enrage soldering purists. Putting the solder on the iron and then bringing that to the joint is considered a big no-no in many circles. But my counter-argument is the only reason that's a bad idea is the flux in the solder has burned away by the time you get the solder to the joint. But I've flooded the joint with flux that will work in exactly the same way as the rosin core in the solder. Anyway, feel free to burn down my comment section. It's all lovely engagement for me. The anchor points on this slot are not as big as I'd like, so it's important to get a good flow going on these pads to give it strength. At the same time, you can't dwell too long with the heat as there are delicate plastic parts inside here that will deform if melted, so the Goldilocks amount of heat is applied. A little test to make sure it still works. Good stuff. What's next then? We have a choice of bits here. The power LED looks like it might be next. Now, I've since learned a bit more about basic electronics, and by the power of Google, I can tell you the long leg is the positive or anode on an LED. And you can just make out on the board that one of the pads is a square, and that normally denotes a ground connection for LEDs, meaning the positive is meant to go into the round pad. Meant to. You have no idea how frustrating it is watching yourself make mistakes. I've been using this Dandanator regularly for months since I built it. I've still not changed that LED. So lazy. A couple of selector switches next. This dip type switch is used to enable the Arduino Uno to be programmed, also for some joystick functionality which I've never used. A switch is a bit neater than a pair of jumpers. And it's only now as I edit this that I realise I'm putting this in the wrong way round. Ah well, it still works. Next is the DE9 connector for the joystick. This is not a DB9, there's apparently no such thing as a DB9, even though I spent the last 40 years calling these DB9. Am I too old to change now? Probably. An extra splodge of solder in the anchor points for added strength. Looking good so far. These long buttons are designed to be able to reach up through the case. I'll be printing one of these for later in the video. The last few months of using it, I've left the board naked and unprotected. I need to fix that. A quick clean up, not much more needs to be done here. The Arduino board will be soldered direct. The 2 rows of pins can be tricky to get lined up by eye. It's much easier to drop the whole thing in the board and solder it in place in one go. Right, that's all the soldering done. No more soldering for me. Just need to fit these chips in the right way around. Oh, wait. You idiot. Wouldn't be a more fun making it video without me making a pig's ear out of something. Removing freshly soldered parts is usually nice and easy, especially when you use leaded solder. My desoldering gun was being a bit of a pain that day and blocking up repeatedly, not sure why. The solder is fresh and new, so no contamination. Well, that was easy. Socket practically jumped out of the board. Ah, my old secure soldering iron. I don't miss that crashing every 5 minutes. This gowl must have been harvested from something. There's a blob of solder on 1 or 2 of the legs. And the very last job is the edge connector. I've done a few of these now and I find them quite enjoyable. The trick here is to bend the 2 rows of pins so they're just narrow enough to grip the board when you slide it in between them. Makes getting it lined up really nice and easy. Then plenty of flux and a good amount of solder to keep this connector in place when it's under stress being inserted into a spectrum. After I got this up and running, for the next number of months, I used this almost exclusively as a diagnostic card on all the broken spectrums I've been repairing. More coming soon. And just as a diagnostics tool, it works well. But it can do so much more. instant loading of games, Kempston joystick interface, snapshot generator, game trainer functionality. It can even be a hard disk of sorts for a +2A or a +3 Spectrum. For me, it's a great game loader, supporting many different formats in which you might find Spectrum games. It's a bit of a shame it's not commercially available, but the creators of the project are entitled to share in the way they think is best. And it's not an impossible or even very expensive thing to acquire if you know the right person. I'm thinking about making another AMIE version for myself. I do like that version just a bit more than this one. If anyone's interested in organising a batch, let me know. Or I might even do that myself. Okay, I finally fixed the broken LED. And even printed a nice case for it, which wasn't available at the time I built the board. Eventually, if it really annoys me, I'll turn that dip switch around too. Here's a quick demo of the interface in action. Pressing 2 will launch the multiply interface, giving you access to the SD card contents. Once in here, Q and A move the selection up and down. Cap shift and symbol shift move the page up and down. Enter selects. It certainly beats waiting around for a tape to load, although I do think that's part of the adventure anyone interested in this generation of computers really should experience for themselves.
Oh. Yeah.
That and RAM pack wobble.
Oh, I didn't see the blue ones. Ah.
Pressing the right button on the card itself returns you to the menu screen, and pressing the left button will generate a snapshot which you can instantly return to.
A snapshot. Cool. How do I get to the snapshots?
And to prove you can never truly know everything and every day is a voyage of discovery, watch me realise there's a second screen I never knew about on the main menu.
Oh, there's another. I never knew that. I never knew this was on here. What?
If anyone fancies sourcing the parts for an AMIE version, please let me know. I'll be interested in replacing my one. It's a fun thing to build, not too difficult, and an incredibly useful addition to your toolset. Hopefully, I'll have a few more build-type videos coming up in the future. It's nice to keep mixing things up. Some of the more simple ones will appear on my second channel. You can find a link in the description, or you can just search for More Fun Making It Too.
Don't know why I do that.
Do you subscribe to the channel? Wait, where did everyone go? Nobody listens to this bit. I'm now just sat here talking to myself. Here's a picture of a weird bird I saw in my tree. Internet points for anyone that mentions this in the comments.
Ah. Nah. Right, gotta go.